Hi everyone, myself Sahil G. Kiroji pursuing BTech in AI/ML in GM University. So, this is a topic about design a fraud detection model that classifies transaction as fraudulent and non-fraudulent. And in my team there are four members: Rohan DR, Rohit Itigi, myself Sahil G. Kiroji, and Shiv BC. Like, fi- and this topic is about figuring out which payments are real and which ones might be suspicious or fake. Since online payments and banking are so common now, fraud has become a big problem, and that's what we are trying to solve here. What we did in the project is a build model that can automatically classify a transaction as either fraud or not. To do that, we used some machine learning techniques, especially ones focused on finding unusual or anomalous pattern in data. We started with a real data set like one you might can find and Kaggle and cleaned it up first. Then worked on picking out which features or details in each transaction might help our model understand what fraud looks like. After that, we tried out a few different algorithms like KNN, decision tree, naive Bayes, isolation forest, and SVM, and compared how well they performed. In the end, we evaluated everything using common matrices like accuracy and F1 score to see which model gave the best result. This gave us good understanding of how fraud detection system works and which methods are most effective. Now we are going to explain all these contents: introduction, problem statement, objectives, methodology, explanation, results and findings, conclusion and reference. And in the next page, introduction. Fraud in a financial transaction causes financial losses and trust issue. This called fraud in an online transaction can lead to a big financial losses and loss of trust. Objective: build a model to detect fraudulent transaction. The goal is to build a model that can detect if a transaction is fake or real. Anomaly detection techniques will be used for identifying suspicious activities. We will use anomaly detection methods to catch unusual or suspicious activity. And in the next point, the study will evaluate the effectiveness of these techniques in detecting fraud. Finally, we will test how well these techniques work in identifying the fraud. And in the next page,
Thank you, Sai. As myself, Rohit Chitigi from AML branch, as we go on to objectives, these are the main objectives of our model. And here, classifying transaction as fraudulent or non-fraudulent and use anomaly detection techniques, evaluate model effectiveness, and comparing performance across machine learning models. And here the methodology and this methodology involves some following steps. Data collection. Here data collection means a publicly available data set where we can access any kind of data set such as credit card fraud detection data set here will be used. And data pre-processing, handling missing values, featuring scaling and encoding categorical variables. This is done by the data pre-processing. And feature engineering means identifying key transition attributes that help differentiate fraudulent from legitimate transitions. As you go on to the next slide, and our fourth point is model selection. For this implementing this model, we use anomaly detection techniques such as KNN means K nearest neighbors and decision tree, naive Bayes, isolation forest, and support vector machine SVM, and model training and testing. Splitting the data set into training and testing sets, training the model and evaluating the performance of this model. And evaluation metrics, performance assessment using accuracy, precision, recall, F1 score, and ROC AUC. This includes the evaluation of this module. And here we can see the demonstration of the flowchart. data collection, data pre-processing, feature engineering, model selection, model training and testing, performance evaluation. These are the main uh, approvals which we use in this module. And the next slide will be explained by my friend Rohan dear.
Thank you, Rohit. I am Rohan Dayar from GM University and I am pursuing AML in AML and I am now explaining the fraud detection techniques, supervised learning approaches. These use label datasets, which means past fraud cases must be known and annotated. The model learns from the historic data to predict future fraud transactions, unsupervised learning. These are useful when fraud patterns are known. They detect anomalies by finding deviations from usual behavior without needing labeled data. Hybrid approaches, the combine with supervised and unsupervised method. This tend to improve detection accuracy by using strength from both techniques. And now, this is the comparison of anomaly detection techniques. The technique, KNN technique. The pros is easy to implement and cons is computationally expensive. The decision tree. The pros is interpretable and the cons is prone to overfitting, no bias. It is fast computation but assumes feature independence. The isolation forest. It is efficient large datasets but less effective for high dimensional data. SVM stands for support vector machine. Effective in high dimensional space and it requires parameter turning. And in the next slide, I am going to explain the result to demonstrate the fraud detection model effectiveness, various model performance comparison will conducted. The result will present in the form of for as you can see in the example one, the transaction classification. This example shows how the fraud detection model classifies financial transaction and compares its prediction with the actual labels. The model is trying to predict whether the transaction is fraudulent or legitimate, means non-fraud. For example, in the table transaction ID 1003 had amount of $5,000. The actual class is fraud. The predicted class is fraud, and it predicted correct. And as you can see in the example, in the table transaction ID 1001 had the amount of $50. The actual class is non-fraud. Predicted class is non-fraud, and it is correct again. These patterns continue for 10 transaction. This model made 100% correct prediction for this small test set. It correctly identified all the three fraud transaction IDs, that is IDs 1003, 1006, and 1009. It also correctly ignored all the non-fraud cases. And thank you. And next part is explained by Shivkumar.
So thank you, Rohan. Myself, Shivkumar, pursuing in BTech AML JM University. So here in this slide, it is an example for confusion matrix for fraud detection. So this slide represents a confusion matrix, a crucial evaluation tool in machine learning used to access how well our fraud detection model distinguishes between fraudulent and non-fraudulent transactions. So here the matrix compares actual values against predicted values. So in this example, the true positive it is 8, fraudulent transaction correctly identified as fraud, and the true negative is 10. Here, legitimate transactions correctly identified as non-fraud, and the false positives is 1. Here, it is a non-fraudulent transaction wrongly flagged as fraud, and the false negative is 1. Fraudulent transaction missed and classified as non-fraud. So this matrix helps measure precision and recall. Precision means how many predicts frauds were actually frauds. Recall means how many actual frauds did we successfully catch. So coming to the next slide. So in this slide, it is a conclusion part. The assessment successfully demonstrate a fraud detection model using anomaly detection techniques. The key points to emphasize is It explores different machines learning's method to catch fraudulent activity. And then the study finds that hybrid models often works best, achieving a good balance between precision and recall. It also opens up paths for further improvements, such as using deep learning for more advanced pattern recognition and implementing real-time detection to catch fraud as it happens. So this is our project, and the references that we have taken from the study references fundamental text and data source such as data mining, concepts and techniques by Hand et al. And the outer analysis by Agarwal, and a credit card fraud dataset from Kaggle, a popular platform for data science compression, and additionally research papers on anomaly detection techniques in fraud detection. So this is our project. Uh, Here I am thanking everyone, my teammates, and the GM University for giving the opportunity for doing this. And thank you, Anusha ma'am, for giving opportunity. Thank you.